So last time we looked at section 4.4 and we looked specifically at side similarity or congruence, and we looked at side angle side. We did say that the angle had to be the included angle. So you can see here in this one with the angle side angle, we're going to have the included side because it's the side that is in the middle or between the two angles. And I'll show you that. But these are tests for congruence. Both cases are. So we have angle side angle with the included side. And then we have angle side, which is not the included side, which is interesting that we have both options. But those are ways of proving triangles are congruent. So if we have this situation, we can say the whole triangle is congruent, which means all the corresponding parts of the congruent triangle are congruent. So even though we've only got two angles in one side in this case, we will say everything, all the corresponding pieces, or these two angles on the side, not included, would be the same. You could prove the whole corresponding set of sides and angles are congruent. So as I said, this is the angle side angle where the side is the included side somewhere. It says that here, included side. And you can see the included side between the two angles. It's the side that touches both angles. It's included in the two. So this just, I guess it's the same thing as this slide just blown up. Yeah. So this is what we're dealing with today. Angle side angle and angle side, just to reiterate that. This one is the angle side angle. We'll get to the angle side in a bit. So I did want to mention why we don't have angle theorem. And that is because we already know we can't have angle. We said that in a previous lesson. And the reason why is because if you look at this, these corresponding angles would all be congruent. But it's obvious to us that these two triangles are not congruent. Now, these two are, because not only are the angles congruent, but the corresponding sides are congruent. Okay. So this says write a paragraph proof. Listen, I'm not so much interested in you being able to write a paragraph proof as I am interested in you being able to think through how these things work. So we've got this picture, and this lower part below the line was not in the original problem. Okay, I'm going to erase that line because I don't want it in the way, but it was not in the original problem. But I want us to write a paragraph proof. Like I said, I'm more interested in, can you think through this? I've noted here that we're going to do a trick, what I call a trick, or just a little insightful thing. We're going to pull the pieces apart. So you see this pulled apart creates these two triangles. And so this is N, this is J, and this is M. This is L, this is N, and this is K. Hopefully you can see that. So it gives it clarity when we pull it apart and we start doing some of this labeling. Now they tell us that these two angles are congruent, so I'm going to mark those. So NKL is this one, and NJM is this one. So those are congruent. They tell us that right away. Next, they tell us that these two segments are congruent. So that's KL and M, or KL. Now I got that right. KL and JM. Okay. So they want us to prove this, which happens to be I'll just touch it, the LN and MN. They want us to prove those two things are congruent. Well, if I somehow could prove the two triangles are congruent, then it wouldn't be too bad to say corresponding parts of congruent triangles are congruent, and we'd be in good shape. So that's sort of my plight, or my mission, is to somehow prove the two triangles are congruent. The thing that I would say to look at is the fact that this angle here is congruent to itself. Look at it and think about it. It's really just this angle up here, just mirrored into both of those triangles. And then we have angle, angle, side. Angle, angle, side. So I'm going to write the congruence thing. So I'm going to write J, M, N. That was a choice, right? Choose what letter I want to start with, go in the direction I want to. That's what I got. So let's look and see who corresponds to J. Who corresponds to J? Well, that's obviously K, because they both got the single mark, so K. Who corresponds to M? M is here, and it's the one with no angle mark, so that's L. And finally, the N. N is here, it's the double, and it's congruent to itself. So remember what what we were asked to do was to prove this. So LN is the last two letters, and MN, that's the last two letters. Corresponding parts of congruent triangles are congruent. We are done. Now, I didn't write that out in a proof, but like I said, we could have written those things down as we were going, but I'd like for you to just be able to plow through these and logically see them, because that analytical capacity is just really, really vital to use in this geometry class. So that's terrific. They got real fancy and said that those two are congruent by the reflexive property. I never mentioned the reflexive property. That is certainly part of being sophisticated, I guess. They did do the congruent statement. It may look a tiny bit different than ours, but it's still the same pieces and parts. And so they said the corresponding parts of congruent triangles are congruent. I want to remind you that in a congruent statement like this, you can say first letter congruent to first letter as far as the angles, and the second letter to the second letter as far as angles, and then the third letter and the third letter as far as angles. So the corresponding angles are congruent. Also with corresponding sides. So look at the AB and the MN. AB is the first two letters, MN is the first two letters. Look at the BC and the NP. BC is the last two letters, NP is the last two letters. And I'm betting that these two are the first and last letters of each of those. But it's just what we have. It's just the way we know that works. So we've got this little problem. It's pretty interesting in a way. I guess it's not like phenomenal interesting, but it's kind of interesting because you've got an envelope that's been unfolded or not folded yet. It's kind of like, how do you take a piece of paper and make an envelope? Well, this is kind of it. And you can see if you fold this flap and this flap, and then fold this flap, and then have this one up here with the glue on it maybe, then that's how you would do that as far as creating an envelope. I got the picture blown up from what the original problem was. It says Barbara designs a paper template for a certain envelope. She designs the top and bottom flaps to be isosceles triangles. So that's why they have the base angles marked congruent in both of those. And if I might add, if the base angles are congruent, guess what we can say about the legs? They're also congruent. It says that have congruent bases and base angles. So that being the case, they've marked these two. So I need to go back and work on my purple markings because I don't want you to think that that's necessarily congruent to the one that's marked in red. But they are congruent to each other, and that's what they told me about the top and bottom and all that. Then they tell us that EV is 8. Now, EV is this side here, 8 centimeters. The base, in other words. So I would imagine this is 8 centimeters off because they said those were congruent. And it says the height of the isosceles triangle is 3 centimeters. Find PO. I'm thinking that the height, let me get me a different pen here. The height, see right here, the height of the isosceles triangle is 3 centimeters. So that's that. So you've got this triangle. I'm just going to try to trace it out a little further or a little more and do it halfway decent, neat. Well, that's a squiggly right there. All right. But they tell us this is 3 centimeters right here. And they ask us for PO, which is this side here. That's what they're asking us for. It would probably be helpful for us to understand that if this is 8 from P to L, then right here, that's going to be 4 centimeters. And, of course, another 4 centimeters. Now, how do we know that? Well, because these are isosceles, you could do some things and prove that these two triangles are congruent. And so you could prove that those two had to be congruent. So it's 8 total, it'd be 4 each. That said and done and all and out of the way. Let me see if I can erase those little pieces. Okay. That all said and done and out of the way, we want to know the length of this side. Let me just call it X for the moment. That's the measure of that side. So this should be a right triangle where we know the two legs. This one's 4, this one's 3. So that's C squared equal A squared plus B squared. C squared, which is what we're trying to find here, the hypotenuse, is equal to A squared, which one of them's 4 squared and the other one's 3 squared. So C squared is equal to, that's 16 plus 9. C squared is equal to 25. C is equal to 5. That's the measure of this, 5 centimeters. And yes, that's the answer. Okay, here's a problem. It does have this. It says, which method would you use to prove those two? I've blown that up. I've taken away the ABCD options, but hopefully we know those ABCD options. And so we have this problem. The curtain decorating the window forms 2 triangles at the top. And hopefully you see the 2 triangles. It says B is the midpoint of AC. So it means that is congruent to that. I'll put a double mark just so we have it. AE is 13, so that's 13. And CD is 13, so that's 13. which means, I'm going to put 3 marks here. It means those two sides are congruent because they're both 13. It says BE, segment BE, which is this one. You can't see my pen, can you? BE and BD use the same amount of material, 17 inches. So that's 17 inches and 17 inches. It says, which method would you use to prove that the two triangles are congruent? Which method would you use to prove the two triangles are congruent? It looks to me like it's side, side, side. Because you've got, let me use a different color here. You've got these two sides that they told us were congruent because they said B is a midpoint. So that led us to that. We've got these two sides, which they told us are both 13. And we got these two sides, which they said both use 17 inches of material. So it looks like corresponding sides in all three cases, side, side, side. So that answer is A.